Thank you. Thank you, Alexandra. Thank you, everybody, for being here today, this afternoon. The idea is to talk a bit more in detail about the work we are developing in the subtask A of task 59, together with the parallel project Atlas. And I will talk through this result of the work we've done to reach this result. Just briefly, 3 slides. I guess it might not be necessary in this particular context. I think we are all aware of the importance of historic buildings, but just some numbers, maybe a bit more related to energy. Just a first remark, we do not consider historic buildings because of the level of protections, whether they're listed or not. We are not considering historic because they are old or new, but we do need to define some criteria to quantify with how many buildings we're dealing. So just to have a first rough estimation, if we look at the number of buildings that were built before 1945, we know that it is around a quarter of the total building stock. That means that when we zoom out, if we look at the whole picture from a bit more distance, we realize of what a big task we are facing, that we are dealing with a huge amount of buildings, that the building stock we are trying to improve, it is actually very, very large. There you go. That also means that the renovation of these buildings has a huge potential. If we manage to renovate all these buildings, we are looking at a potential saving of 118 megatons of CO2 per year. Every year, once these buildings are all renovated, we are able to save that much CO2. However, to reach this value of to renovate all these buildings by 2050, we need to renovate them at a rate of 3% per year. Our current rate is far below that. Depending on the study that you look at, this rate is between 0.4 and 1.2% per year. And that includes the renovation of any building. We do know that historic buildings renovations is even lower than that. It means that we have a very ambitious task that could provide a huge saving in terms of energy, but we are really far from reaching that goal within 2050 as a target we have set ourselves. The idea of the picture to the right is to make a contrast or to illustrate the difference in technology or the difference in performance that technology has developed over the last century, let's say. This picture of the Wiesenhof in Stuttgart shows what was the state of the art in terms of construction and construction technology, but also the state of the art of automotive technology at that time. That was the best performing building and the best performing car. The car is completely outdated, whereas the building is still, in many cases, at a similar level of what most of our building stock is doing. So we do have a contrast in the technology development implementation in the real case. So what we are looking at is a development of a database of best practice solutions that show energy-efficient renovation of historic buildings. I think throughout the years of the projects that were already introduced earlier today, we've seen in the literature that the technology is not a problem anymore, or not on its own. It's the social technological barriers that are preventing the implementation of these solutions. We have the technology, we know how to do it, but we are actually not finding a way to convince people of implementing these solutions. And the idea is that this database will gather all this information that comes from research, but also from the more courageous or advanced or front runners, architects and building owners that have decided to renovate their historic buildings, that have learned throughout the process, and that we can gather all that information and pass it on to other ones and to use the strength of an example to improve the knowledge of how to renovate these buildings, but most importantly, to convince others to renovate their own buildings. These are just some of the examples we are working and including in the database. Our colleague Julien will talk in more detail about one of them. And the idea for me today is not to talk in much detail about any of these case studies that you can in any case see in the website or in the panels that are outside, but more explaining the structure for the database and how we got to the idea of that structure, the why behind all the decisions we've made in this process. So the idea it is document best practice of historic buildings, and we needed to start by defining what a historic building is and what a best practice is. As I said in the beginning, and that is very important for us, so we repeat it, independent of the audience, historic building is not necessarily listed and is not necessarily old. It can be a medieval building, but also a post-World War II building, and it is independent of whether it is listed A, B, C, or 1, 2, 3, depending on the context you are, or not. If you consider that this is a building that is worth preserving, that it has some features that are worth keeping, it is worth approaching the renovation of this building with the perspective of a conservation compatibility. And from the other side, what makes a Renovate solution a best practice to be included in our database? Just as a first remark, and that's the result of long and many discussions we have had within the Task 59 group, best practice doesn't mean perfect. It's more of it has reached a level of excellence that can be communicated to others. And what is important, and that these sort of exemplary buildings are exemplary both in energy efficiency and in heritage compatibility or conservation compatibility. So the first requirement or criterion that we had included in our, or that we have defined for the case studies to be included in our repository is that the intervention has to be completed. There is enough case studies, theoretical case studies, that actually don't manage to convey the information or to convince the reader, because there is always the implementation part, the practical part that is missing. We want to learn from those projects that have been already implemented and that have faced all the problems and limitations that come with implementation. Then we want to look at a building as a whole. We don't want to just renovate or exchange windows. We don't want to just exchange the roof. We want to look at what the building as a whole can achieve if looking at it holistically. And that is because we are looking at aiming at a significant reduction of energy demand. And as Alexandra was presenting in the first talk today, we are aiming at lowest possible energy demand. The only way we can reach that lowest possible energy demand is if we look at the building as a whole and not as a single elements that can be taken separately. Because of the context and because we are very aware of the limitations, we decide that it doesn't make sense to set a target or a threshold in terms of kilowatt hour per square meter, but rather to define this negotiation space, to define this context in which we move around and where we try to reach the lowest possible energy demand. Then, obviously, the energy reduction cannot come at the expense of the heritage conservation. We cannot sacrifice one for the other. On the one hand, we are saying we don't leave these buildings wasting energy because they are heritage, but on the other side, we cannot accept, we say we renovate these buildings because we need to save energy, and then we sacrifice heritage. The only way we can be sure that this is not happening is if the renovation process considers heritage, what elements were worth preserving, and how they were included in the whole decision-making process. Therefore, a project to be included in the best practice database should have gone through a complete or a thorough heritage assessment evaluation. And eventually, the only way we can communicate all this information and we can communicate the whole story is if we have a whole documentation or a complete documentation available and we can share with others. Then, how we document these buildings? We start, or let me first say, we try to target two main groups of audience here. On the one hand, we had the building owners, those that actually own the building and that have to take this first step to decide to go for a renovation. And on the other hand, the technical side that will help the building owner and encourage the building owner to pursue a more ambitious energy renovation. That means that we're talking to two different people, two different target audiences with different levels of understanding and different levels of interest in the technical aspects of the topic. So we always start from the view of the building owner that is interested in maybe browsing among many different projects and get a general feeling for these renovations. And then later on, we get deeper into the details that can be looked only in some of the cases and maybe for only some of the stakeholders involved in the whole renovation process. So the first step is we show some images of the building after the renovation to motivate, to encourage the building owner to pursue that renovation. And we try to summarize a whole building and a whole building renovation into a number of items that can tell you how the building performs after the renovation, which construction period it was built, what kind of construction technology it was used, building typology, surface area, and so on, just to give a first impression to the building owner how much this building could relate to their own building. As I said, there is always a second step. So if you need to know more, if you want to know more, there is always going to find this feature where you can add more information. And this single criterion develops into a series of criteria, into a whole group that gives you more detailed information. So it's not only about how many kilowatt hour this building is using, but also to know the context in which this building is being operated. In order to compare buildings and how efficient these buildings are, we need to know the climatic conditions, and in this case, we added information about the altitude, the location, the heating degree, and cooling degree days. And the same for all the other categories. So where it is listed, but also in a conservation area, and so on. On the second step, we want to tell a story. We want to say, from the very beginning, how was the building, what was the building, and in which condition this building was found when the renovation started. So we have a more narrative story in which the authors describe the whole process. And we accompany that with the with images of the building before, during, and after the renovation. Again, every step along the way can be extended, can be enlarged for those who are actually looking for more detailed information. So maybe a building owner just needs to know in a first stance the description of the building as a whole, but on a second step, maybe they want to learn what were actually the single elements that were worth preserving in that case, and how the heritage value assessment was carried out, how was the state of repair of that building, or the conditions of the envelope. Those preconditions that explain, that justify the solutions that were adopted afterwards. We cannot recommend solutions if we don't understand the context in which these solutions were adopted. We definitely need to understand the why of each single choice that was made along the way. Then, once the context, once the decision-making process, the team involved in the project and so on was explained, we can get into more detail about each single retrofit solution. So we have structured them around different elements of the building envelope and building services. We start with external walls. We have a short description in which we explain what the solution is about, and a short description on why the solution is compatible with the conservation of the heritage values of that particular case. That is all described in the text here, and is always followed by images of the wall or the single solution that is explained in that case, and it always comes with images of before and after the intervention and some construction details of that particular element. Again, the information can be extended and can get a little more technical. So we not only say how this building, how the wall element was, but we also found a way to make visual the whole stratigraphy of the wall, so we can give an impression on how this wall was built. In this case, you see that it was a stone wall with plaster both inside and outside, and that was renovated by adding to the inside thermal insulation plaster. On top, you see the U value before and after intervention, so you get a bit more detailed idea of how the whole intervention in the external wall was. The same happens with the windows, with the roof, ground floor, airtightness of the envelope, and so on. A similar structure has been chosen for the building services, so all HVAC components, heating, ventilation, and air conditioning, and to the renewable energy systems. If there was any renewable energy source included in the renovation of the building, we follow the same structure. We explain what the solution was, why this solution is compatible with the building in this particular case, and then we get into more technical details about this specific solution. The last part of the documentation of each single case study is about evaluation. We don't only want to tell the story about the building and how well the renovation was or worked. What we want to actually show is the results of the evaluation of that intervention. Obviously, the results are not always homogeneous. Not everybody has the same exact information, but we do provide the same structure for everybody. So we are trying to communicate results of the evaluation in terms of energy efficiency, improvement of the internal climate, the cost, so whole financial assessment, and environmental aspects. So if we look, for instance, at the energy section, we have the possibility to share how the energy consumption before the renovation was and after the renovation, whether that was measured, calculated, or estimated. And if it's available, you can share the results of your calculation. You can share the results of monitoring, if it was part of a research project, for instance, and so on. And a similar approach is chosen for the internal climate, for the financial analysis, and for the environmental aspects of the evaluation. We are aiming for big numbers. We hope by the end of this project to have over 100 projects, and we want this database to continue alive after the end of the projects. So we are aiming at a big sample of buildings, a big sample of elements. And therefore, we need the measures to filter these buildings so we can provide the building owners with the tools to find the buildings or the elements, the objects that are more significant to them. So they can actually find the buildings that mean something to them. So we have implemented different ways to filter the buildings, first by their name, by different filter categories that we are currently working on, and that will be construction period, location, climate zone, wall typology, internal insulation, and so on. And eventually we will have them all display on a map so you can actually browse and look at the buildings that are in a certain area. So this is a lot of information that is being gathered and that is being included and shared in this website. Now we need to find who is doing it. At the moment, there are 2 research projects that are feeding into this database. We have the International Energy Agency HHC Task 59 as one of the main contributors, as it was presented today, but also the EURAC Alpine Space Project Atlas is contributing to the development of the website, but also to provide cases in the Alpine space that can be documented and shared in this website. So it is all about connectivity, about gathering the efforts that have been done before, trying to organize them in a structured way and share to others so we can maximize the impact or the results of all the research and innovation that has done before. So these 2 projects are collaborating together to gather hopefully over 100 case studies of exemplary renovation of historic buildings before spring 2021. But we do want that this whole database and this whole compilation of exemplary case studies continues beyond that. We have worked with a structure of a database that is compatible with other resources like the Construction 21 platform, but we are definitely open to collaboration with other research projects, with other institutions, with national heritage authorities, and so on. I don't think I need to say much more about the Task 59, just that it's a project that looks at the gathering a solid knowledge base that assess replicable procedures and tools, and that identifies conservation-compatible retrofit solutions. The structure of the partner project, Atlas, from the EURAC Alpine Space, looks instead at 3 different scales, or 3 different scales. Starting from the development of a knowledge base that looks at a whole building renovation, but we also look down into the single element, and we're trying to identify, assess, and optimize conservation-compatible retrofit solutions, but we also zoom out to look at the whole regional or municipality level and trying to develop and implement strategies to help the municipalities in the implementation of decision of renovation policies that encourage the energy renovation of historic buildings. And eventually, also in the Atlas, we have a strong focus on exploiting the knowledge gain from all the best practice that we gather in the first point, and we manage to, from these best practices, learn the lessons that can be communicated to policy, research practitioners, and the general public. So my last message, and from my personal point of view, the most important, we have done this work to put together a website, a compilation of case studies, and we've managed to make it available online just before this conference. So please visit this website, and it's still in a beta version, so any bug, any problem that you find along the way, please don't be too harsh on us, and instead communicate anything that you find, and we will try to change it and improve it as soon as we can. Thank you very much.